Hi, I'm Damiano Piovesan. I will give you today a brief introduction of the curriculum of Biological Data Analytics of the course of Data Science at the University of Padova. Well, we are now living in the omics technologies, which open new frontiers in biomedicine and biotechnology. In fact, modern life science is based on high throughput experiments, which generates data, which requires interpretation. And of course, this interpretation can be possible just adopting computational technology, advanced statistical analysis, and mathematical tools. In the market, there is a great need for specialists and analysts in research institutions, hospitals, pharma, and diagnostic companies. Well, this is an example of the protein folding problem. So the problem is, starting from the sequence, determine the three-dimensional structure of a protein. Historically, this problem can be solved adopting a brute force approach, for example, simulating physical forces and then generating the force field and the movement of the atoms until the three-dimensional structure is obtained. Well, with the advent of machine learning, and specifically very recently with the adoption of deep learning, the AlphaFold algorithm can generate the three-dimensional structures, let's say, from the sequence in hours instead of years of calculation necessary for molecular dynamics to get a reliable solution. And the new algorithm has been developed by the Google DeepMind lab. Another example is what is called precision medicine, which will represent the future of treating a disease. In fact, at the basis of precision medicine is the fact that a disease should be understood at the molecular level. And so knowing the molecular mechanism underpinning a given disease, we will be able to target precision medicines against the cause of the disease rather than just simply treating the symptoms. Well, there are several companies already working on that subject. One example is 23andMe, which scans your genome just looking for specific locations, and with that is able to say something about your ancestry or something about your traits. But scanning the entire genome, it will give you the opportunity to also tell something about genetic diseases or tell you something about optimal dietary profile of your organism or your genome, which is very promising to improve the health and to give an opportunity to cure several diseases which are actually very relevant for the society. What about the biological data analytics courses? Well, it is a mixture of math and bio courses. The math part is focused on statistics, applied mathematics, but also machine learning algorithms and tools. The biological part is concentrated in molecular and cell biology, and computational biology and bioinformatics. Prospective students' background can be computer science, computer engineering, mathematics, statistics, physics, but also we accept people coming from biology, medicine, and related bachelors, maybe with an emphasis on some additional course on math and statistics. Prospective students should have an attitude on both basic science and computer science. They should enjoy knowing more about biology and medicine. What we expect from students: tackle computational biology problems in a scientific, evidence-based manner. So you are working with real biological data, so this is a very important point. And they will gain experience working in a true multidisciplinary mindset. So mixing biology and math gave this opportunity. And also one important thing is the effective management and exploitation of high throughput experimental data. In addition, students will have the opportunity to perform real lab experiments and understand molecular data and how are they generated, which is very important to understand which are the problems to generate some specific kind of data. What to expect? Well, mathematical and computational methods in computational biology and bioinformatics, advanced machine learning, optimization, and algorithms to model biological phenomena, analysis and interpretation of a large dataset, those, of course, coming from the omics technology, and fundamental aspect of cell biology. Our graduates will have basic knowledge of life sciences, an ability to deal with omics data, and ability to model molecular system, which is an effective and attractive professional profile, and there is an excellent placement in the job market. So employment prospect, for sure, biology and healthcare, both in the companies and the research institutions, also drug design in pharma companies, precision medicine, diagnosis, and so on. So this is the structure of the course. There is a number of biological exams, for example, structural bioinformatics, biological data, but also there is a number of mathematics, statistics, and computer science exams. We will give you a background, very strong background in machine learning and mathematical tools necessary to approach the interpretation of biological data. Then there will be other 2 optional and 2 elective courses from computer science or biology, and the elective will cover 12 CFU. This is the structures of the course for the along the 2 years. So in the first semester there will be a focus on statistics, mathematics, and machine learning. In the second semester, from the second semester, we will be starting to introduce to more biological exams, introducing bioinformatics, molecular biology, but still focusing on the statistics and data analytics courses. On the second year, again, there will be a number of biologically related courses, plus 1 course to be chosen from bioinformatics, law and data, mathematical cell biology, and omics in human disease, and another course chosen from human data analytics, game theory, and network science. So at the end, on the second semester, an internship and the thesis will you the necessary CFU to complete the course. This was pretty much what I wanted to say about the course. I hope you will enjoy to participate and to choose this course.